This lecture we're going to start chapter 15, Energy and Chemical Changes. We think of energy as things like glowing campfires, the sun. If you rub your hands together, these all produce energy. They all release heat. If you melt ice or if you boil water, then we have to absorb heat. We have a law of conservation of energy. In any chemical or physical process, energy is neither created nor destroyed. All of the energy can be accounted for as, and I made a mistake here, we don't need this one. It can be thought of as kinetic energy or potential energy. We can transform energy. Gasoline is stored potential energy, chemical energy. When it explodes inside the pistons of the car, we transform the potential energy into useful work or kinetic energy. So energy is the ability to do work. Here we have a girl holding a ball on a cliff. So it has a lot of potential energy, but as she lets it go, the potential energy turns into the kinetic energy of motion of the ball falling. So if we go to the next page, let's take a deeper look into heat. Heat, which is given the symbol of Q, is the transfer of energy from one object to another because of a temperature difference between them. Heat always flows from a warmer object to a cooler object until the temperature of both are the same. So if you are holding an ice cube, you are not absorbing cold. The ice cube is absorbing energy from your hand in order to melt. Heat always flows from hot to cold. We have a term called heat capacity, the amount of heat needed to increase the temperature of an object exactly 1 degree Celsius. It depends on the mass of an object, how much of it you have, and the chemical composition of the object. So a steel girder has a greater heat capacity to raise its temperature than a nail does, simply because it has more mass. On a sunny day, a puddle may be cool, while a sewer cover right next to it can be hot. So the composition of the sewer cover is different than water. There's a term called the specific heat. It's the amount of energy required to raise the temperature of 1 gram of, and although I say water, it can be anything, but mostly in this class we're going to deal with water. 1 degree Celsius. That energy is 4.18 joules per gram degree Celsius, and sometimes you'll see it written as a Kelvin, but either way it's 4.18 joules. Water has a very high specific heat, relatively, compared to metals and anything else on that chart. Therefore, it takes much more energy to heat up water than it does to heat up a metal. Once heated, the water will also release a lot more energy when it cools. And this is why Lake Ontario has an effect on our weather. In the wintertime, the water of the lake takes a long time to release its energy. So around the lake, the temperatures stay relatively warmer. In the summertime, it takes a lot longer for the lake to absorb energy, so it stays relatively cooler around the lake in the summer. Sorry if there was a pause there. I'm still trying to figure all of this out. We're almost done. On the next page, calculating the amount of heat absorbed. So we have an equation. It's Q equals mc delta T. You can see what each of the units stand for here. So let's just do a couple of these here. Convert the following. We should know Kelvin equals Celsius plus 273. So if we have 33 degrees Celsius plus 273, it should be 306 Kelvin. Let's look at number 1. The temperature of water with a certain mass increases by a certain temperature. What's the total amount of heat absorbed by the water? So we're going to use ESA. So the equation, Q equals mc delta T. We want heat, so we want Q. M, 29.6 grams of water. The specific heat of water is 4.18 joules over gram degrees Celsius. And the change in temperature, if we subtract, is 27.1 degrees Celsius. So the grams cancel, the degrees Celsius cancels. We have 3 sig figs, so our answer will have 3 sig figs. I got 3,353 joules, but to 3 sig figs, I would say 3,350 joules. And that would be my answer. So we're going to work on the rest of these problems in class on Tuesday, and I will have another worksheet for you to work on. So that is it for today.